So jumping right into it, I'm going to give you a little bit of a summary of the last 8 years of Minecraft plus AI research and why it matters. So, and immediately I hit up, but I was trying to come up with a hook, like, get you into the loop and why this talk matters and stuff. But then I realized that if you come to this talk, I don't think I have to really sell you the thing that we really want to make intelligent AI. So I don't know, you want to call it AI, AGI, autonomous machine intelligence, whatever you want to call it, take your pick. We want to make cool, clever, intelligent agents. I assume everyone agrees here on that, more or less, right? Yeah, gentle nodding, yeah, okay. So meanwhile, if you go to Google Scholar, Minecraft pops up in AI publications quite often. Again, I was trying to find a way, the reason why we care about Minecraft. So I did this very scientific thing of just putting Minecraft or Minecraft plus AI on Google Scholar, and you get 17,000 results with Minecraft plus AI, and more with just Minecraft because people are doing, I don't know, social experiments or other gaming stuff with it. For context, if you put Atari plus AI, again, very rigorous experiment, you get 50,000 results, which is 5 times more. But consider that Atari was de facto like a testing ground for reinforcement learning agents for quite a while. So it's quite impressive that the number of Minecraft plus AI results. So there seems to be interest for Minecraft in AI research. And I just so happen to have spent some time on doing like Minecraft and AI stuff. I've participated and organized a couple of Minecraft AI competitions. I have been maintaining one of the Minecraft environments people have been using for research. And I helped OpenAI release open source their like a foundation model for Minecraft a couple of years ago. So given these two ingredients, this presentation is here to get you up to speed what has happened in Minecraft, why people care about Minecraft for AI research, and what people are up to, I don't know, last week. Hopefully I captured all the papers. So what is the fuss with the Minecraft? Like, why do people in AI care about it? How many here has played Minecraft? Oh, that's actually surprisingly many. I wasn't expecting so many, but that's so good. So I don't have to really explain too much on Tita, but to get everyone up to speed, it's this game, like first person. I hope you can see it. It's a bit thin, but I hope you can still see it. It's like a 3D environment, procedurally generate, consists of blocks. You can go around, explore, find things, or you can destroy the terrain, destroy the blocks, build some things, find new things, build a house, whatever you want to do. Well, not whatever, but you get the point to some degree. And one thing we have to cover a bit more rigorously is item trees in Minecraft. This is a bit more important for the things we're going to discuss later, is the item trees. So, for example, if you want to get a stone pickaxe in Minecraft, you have to follow this series of getting different items that then build up the stone pickaxe. So you have to get some wood to make a crafting table, which is used to craft a wooden pickaxe. And then with the wooden pickaxe, you get stone. And then with the stone and the resources you got, you make a stone pickaxe. And all of these steps are trivial maybe to human play. I will show an example. But from like an AI agent perspective, these take like hundreds of steps each, which is non-trivial, or can be trivial, but mostly non-trivial. And even for humans, it takes to get the stone pickaxe an average of 2.3 minutes. So that's, considering how good the AI agents were, I don't know, 10 years ago, this is a long stretch to get even 2 minutes of consistency from your model, maybe nowadays. So here is an example of human getting a stone pickaxe, just to get everyone to the same level of understanding what's happening and what's going on. So here, a human player, you never guess who, spawns in. There is some trees. Oh, it's a bit choppy, but I hope we will get an idea. Chops some trees. Gets enough logs to slowly start crafting. It's a bit choppy, but there it crafted planks. Then the planks into crafting table. Place the crafting table down on the ground and now craft some sticks needed for the wooden pickaxe. And now using the two ingredients, made a wooden pickaxe. I'm sorry, it's a bit small, but I hope people get an idea. And now with the wooden pickaxe in your hand, you can go find stone and mine that stone. Because otherwise, without the wooden pickaxe, it's just going to destroy and you don't get anything. And now with the 3 stone blocks, you can use it to craft a stone pickaxe. And that's how you get a stone pickaxe. And this is kind of the premise of, at least for when it comes to items, how you build up and get more complex items again. You find the resources, use the tools to get more resources, rinse and repeat. So why Minecraft for AI? Like, why do we care about this game? Just quoting a bunch of different researchers or publications that have used this. Katja Hoffman in a blog post from MSR, on Microsoft Research, Cambridge, highlighted how it has endless possibilities, like building structures and building stuff with your teammates. MineRL competition organizers from CMU highlighted how it's a rich environment. It's a very open world environment with very sparse rewards. And they really specifically highlighted the whole like hierarchy of items. So to get another item, you need the previous items, and then you have this whole sprawling web. Craft Assist from Fair in 2019 highlighted it has no win condition, again, on the kind of open-ended side, and encourages the players to be creative because there is no one specific goal in the whole game. And then highlighted how, say, collaborating in the game, say, building or collecting stuff is a very famous activity in Minecraft. Just a couple of more. BASALT competition, so Berkeley, OpenAI, and CMU, again, highlighting the open-endedness, and they have very rich space of tasks. So there is more to Minecraft just getting items. I mentioned like building or exploring and stuff. We will come back to that later. And MindDojo from NVIDIA highlighted, that, again, no specific reward to maximize, well suited for open-ended research. And then there is this line about generally capable embodied agents, because with all of its open-endedness and rich environments. And this is starting to connect to the part about, well, AGI, MEI, whatever you want to call the super clever agent. So these people say that you could use the Minecraft as like a testing ground for these very complex agents. So with that in mind, let's dive into these decision-making agents in Minecraft. I'm just bit of a disclaimer here. I'm skipping a lot of other research. So there is a lot of research, say, on procedural generation of like how to make better maps in Minecraft and other AI-related things. But I'm focusing solely on kind of deep learning era decision-making agents that act in the environment. And there, I'm just highlighting there's a lot of stuff, other stuff as well. We just don't have time for that. Starting with 2016 with Malmö, to some level, arguably the point for the deep learning Minecraft boom. This is a research environment by Microsoft where it provided an interface to control the Minecraft agent, or like launch a Minecraft, control the agent from Python code directly, and you didn't have to set up anything else. And you had this nice XML structure where you could define the whole map, define the end goals, define the beginning conditions, all the like little settings. So you could construct many little different tasks in this, and they use this to test like maze solving and collaboration with between agents and so forth. 2019, MineRL comes in, and this is where I also step in the terms of competitions and starting to maintain the libraries. MineRL built on Malmö, and instead of just giving you the tools to define all the scenarios, they use it to define the more natural Minecraft tasks in like AI environment. So if people remember back in, well, there is OpenAI Gym, the interface to do reinforcement learning agents. This one brought that to the Minecraft community where it defines, say, an Obtain Diamond challenge, that Obtain Iron Pickaxe challenge, where you join in, start the game, you are in the random world, and your goal is to get an Iron Pickaxe, which is deeper down into the crafting tree, and you have to go and explore. These tasks, these very human-like tasks, are very difficult for pure reinforcement learning to solve. So they provided human demonstrations to help with this work. And they also organized competitions that happened 2019 and 2022, challenging the participants to obtain a diamond. So if anybody obtained a diamond quickest, wins the game, or wins the competition. To show a little bit of an example of how good the agents were back then. So from 2019, an agent using like hierarchy of splitting a task and imitation, a little bit choppy. I hope you still get an idea. It goes to the trees, chops the trees as a human would. A bit of extra logs, maybe even loses some. Goes to another tree, collects a bit more, too many blocks. And the other thing doesn't really come out from this video, but the agents generally were very, what's the term? Not intentional. Like if you looked at them, they go around and they collide to like random things a little bit. But then once they collide to a tree, they cut the tree. Okay, fine. But then outside that, they seem to just go around and be quite blind, and then occasionally do the thing they're supposed to. So this one actually gets quite far in the crafting tree, but you can see it's not very intentional, like puts 2 crafting tables instead of just 1. and then start sticking down directly, which is very hazardous. But it got somewhere. So moving on, once the buttons work. Oh, sorry to cut your fun. But how about solving vague lifelike tasks? So instead of just obtaining items and being very concrete that get diamond, which is, I mean, it's a nice task, get me $1,000 or something. How about solving more vague tasks? So for example, Craft Assist library, which is outside MineRL, they specifically targeted the human AI collaboration via chat dialogue. So they made a system where you can, the human can be like, build me a small house, and then the bot ideally, well, builds you a small house. Basalt competition, part of the kind of a sister competition to MineRL, I was also organizing, is a benchmark for solving these fuzzy tasks. So for example, build a waterfall was one of the tasks. That's all you get. That's like, you get the environment and you join in, and the task is build a waterfall, and you don't get any other really ingredients apart from that. Now, as a human, we probably, all of us here, once you know the game, get some sense of that this is a waterfall, this is not, this is a better waterfall than that. So we used humans to evaluate the results then at the end. But then it was very tricky for the trained AIs to do this because there is no like specific, like a numerical reward to maximize. So these are a couple of examples, bit choppy again, unfortunately, and very short clips. But the takeaway here is that some of them just burn themselves in lava, like the top left one. And apart from that, they just go around and jump around and don't really do anything intentional again. They might look down and then they place the water down and they're happy with it. That's a waterfall, quotation marks. But putting it a bit more quantitatively, there was lots of energy and ambition to get these agents, but it fell short by 2022. So in the MineRL, the diamond competition, in the final iteration, none of the agents was able to reach a diamond. At best, they reached the iron ingot, which is needed to construct the iron pickaxe, and then that's needed to get the diamond. And that's the furthest participants got, given the constraints. Best solutions use like splitting the task into sub-tasks, bit of hierarchy, bit of imitation here and there. For the Basalt competition, the agents were never really preferred over humans. So as a milestone goal for Basalt, we had a goal of if you manage to outperform humans or reach the same level as humans, so essentially human evaluators look at the agent videos of the agent and the human, and they 50% of the time, they like choose agent is better or the human is better. If they reach that level, we would have given them $100,000, but well, they fell quite short. The only exception was if the agent was scripted instead of being a neural network and a fancy solution. Some humans like that because it seems very robotic and a very efficient way of building a waterfall, but it's essentially just 2 blocks, a water block, and it's water falling. So it's a waterfall. Okay, so those were the results. So essentially, TLDR, energy, but a little shortcomings in the terms of how good the agents are. So 2022, the large models and large language models now join the game. Starting off with scaling things up. So MindDojo from NVIDIA introduced this benchmark built on MineRL, by the way, with thousands of tasks instead of just few. They provided a data set of YouTube datasets, YouTube videos, Wikipedia, internet datasets of Minecraft knowledge you can use. They didn't actually provide the videos, they just provide links to the videos. And then a MineClip model that connected the text and the image in the correlation. So essentially you could ask, this is the text, this is the image, are they actually like same meaning? And then you could create things from there. Meanwhile, OpenAI released the same year, 2022, the OpenAI video pre-training, OpenAI VPT. So they did what OpenAI did best, at least at the time, of collect everything from the internet as much as you can, train a big model on that, and profit, essentially. So in terms of how good the OpenAI VPT was, here you can see the performance of the model as it was being fine-tuned by reinforcement learning. So on the x-axis, the further you go, the more training like in the game it has. And then in the beginning, it was already pre-trained on the YouTube dataset. So with a very many quotation marks, because this was a big cluster with a lot of compute, the agent started getting diamonds. And then even bit more training, the agent started getting diamond pickaxes. So more than one diamond, and then able to craft the diamond pickaxe. So this was a pretty clean, overall pretty clean solution. Not too many tricks, not too many hacks, just a plethora of data, a lot of training, Then almost immediately, I think it was like a few months, 3 months, 4 months, somebody took the MineDojo, which connects the text to Minecraft videos, the MineClip model or images, and the video, the DPT model, and combined them into one called Steve 1, where they use the MineClip to fine-tune the DPT model to be controlled by text, because the original DPT model was it just sees the image and off it goes. There is no way to control it. But then Steve 1 added the possibility to condition it on a text prompt. So now you could actually tell what it should do. So here you can see, at the same time you see the quality of the DPT, but also the text condition of the Steve 1. So it says, go explore. It just goes around. Oh, hold on. It's lagging a little bit behind. It's saying collect seeds, go swimming, jumps in the pond, and now it says chop a tree. And if you could see, there is a tree in the distance and it's kind of getting there. It's more like intentional about getting to the tree and start chopping it. Unfortunately, it's in water, so it just slides back and struggles with it. And then after a little while, it just gives up and just jumps back, not chopping it. So that was the peak, 2022. But essentially, somewhat controllable agent. So we have these agents that are very good at, decently good at this individual subtasks, like get seeds, get logs, get trees, whatever. How can we go wider and deeper? So imagine you are in the center where you don't have anything, and your goal is to reach everything. If you want to talk about the whole obtain items thing, reaching all of these items and all the requirements they have. So how do we do this? LLMs, turns out, are very good at splitting this task. So this is, sorry about that. LLMs are very good at splitting these tasks. So especially when, this was a bit surprising, especially when ChatGPT came out, everyone's dazzled by the AI models and all that. And then it turns out you can just tell it that you want to do something in Minecraft, and it gives you a decent split-by-split, step-by-step instructions. So here I asked Meta AI, naturally, of course I have to give me step-by-step instructions how to get the stone pickaxe in Minecraft. And it gives me like a list of, hey, here are like, press this button, do this, do that, very step-by-step instructions. And if you look at it a little bit, it has the different ingredients of punching the trees to get the logs. Next is crafting a crafting table to get the crafting table in the progress. And then you have, further down the line, you have finding stone once you have the wooden pickaxe. So it knows all these necessary steps, which is pretty cool. So we have LLMs that can split up the long task into smaller, easier like parts to solve. And then we have the existing agents that can already complete these smaller tasks. So combining these two, we should have an agent that completes longer tasks, no? And this is the idea many people got around this time. And now we start to get into like the 2023, 2024 LLMs plus whatever way to control your agent. So how to make LLMs interact with the Minecraft, because LLMs output text and Minecraft doesn't work on text, last time I checked. So you could code and name the actions manually. So this work, once it shows up, goes into Minecraft, essentially define the list of different actions to execute. They manually, I think, programmed most of these and then gave them a name and some description, maybe some parameters that you want to mine coal or something. And then they ask the LLM that these are the options you can, these are the actions you can take. And then they ask, what is the next action I should execute? So very simple and works to a degree. You could ask them to write the code. So this might be the paper most of you have heard. So NVIDIA Voyager rings a bell? No? Yes? A little bit of nodding. So NVIDIA Voyager used just program code to define an action in JavaScript. So you can use this library API called MineFlyer to create a bot in Minecraft and then control it with JavaScript. So they essentially asked in Voyager from GPT-4 that create me the program code to do this in Minecraft using this API. And that's the action. And that's how they went. So that works as well. You could train an agent for sub-skill, kind of connecting to the first one, where instead of defining the skills yourself, you use reinforcement learning or something else to train different skills, so finding things or manipulating things or crafting things. And then the LLM is given the list of all the skills, and it then tells that, okay, we should do this next, or we should do that next, and they will complete a bigger code. We can use the text behavior models. So going back 8 slides or something along those lines, we have Steve 1. So Jarvis 1 took the Steve 1 and used it with LLM to, LLM comes up with the plan, and then LLM tells the Steve 1, which is controlled by text, to do the actions in the game. And you go with that. Simple enough, because you already have the Steve 1, why not go with that? And then this is one recent one. So continuation of the Jarvis called Omni Jarvis, where they took a bit of simpler approach, where they just have one big transformer. They turn all the text descriptions, the memory descriptions, the observations, and the actions into like tokens, and they train one big transformer on that. And then they train the transformer to output the ideal actions for these observations. So now you have just one model, you don't have any extra models. That one model is outputting actions. This is very similar to the Gato from DeepMind from a couple of years back, where they tried to jam everything in, and many of these multimodal models nowadays. Right, so that was the actions. But how about the plan quality? So we can control the agent now in Minecraft from LLM. But do you think, if you ask your favorite LLM, although I haven't checked GPT or one or anything, or later Llama things, do you think they will cook up a perfect plan? Like if you ask, give me a TNT in Minecraft, do you think the model will give you perfect plan to get there? No, bit of shaking heads, Yeah, no, I mean, I don't know. I need to ask this again next year. Maybe it will change at this rate. But for now, the plans are far from perfect. So in this case, going back to the example a couple of slides ago, sorry for not being a bit blurry and difficult to see, there are a few errors that are, some of them are just maybe language errors. So it says that press the left mouse button to punch the tree. This will break the wood blocks and drop blocks. It's not exactly correct because it takes for a couple of seconds to hit the tree to break the block. So it might be a language thing or it's just mistaken things. But then further down the line, it says, place one log in the crafting grid and then close the inventory to get a crafting table. But if you remember from the video, you had to put 4 blanks into the crafting grid to get a crafting table. So that's just a factual error. It's just, that's not going to work. So yeah, there are plenty, quotation marks, critical errors. And the authors of Debs, which tried to alleviate this, said, highlight 2 major things with this. So the more steps you have in your plan or the requested plan, the more chance it fails. And the second one is, because of the open-endedness of Minecraft, you can do many of these tasks in a very different ways. And this causes problem because the model doesn't really know which one is the actual optimal way to go about it. So the Debs authors actually worked on picking the solution that's most promising or most feasible. I had a little asterisk there because this is already getting better the last time I tried this example, and I had to repeat this a couple of times to get errors that are very easy to highlight here. So this might change at some point with LLMs just getting better. We will see. So to fix this, you can just regenerate the plan until it works. So going back to Voyager, they check if the code even runs, and then B, they run the model and they check if the state is the expected state. And if not, you give the feedback and you repeat the loop and you improve the solution. And you repeat this loop until you get the plan that actually works. Or you can just ask LLMs to recheck the plan and outcomes, which I still find weird that you can just take one, let the image come up at some point. There we go. you have one, well, I mean, same language model, but with a different prompt, creating the plan. And then you take another, well, another prompt, feed in the plan, and ask the same LLM, does this seem correct? And it improves the results, which is, I don't know, I still find it bizarre. But yeah, this Jarvis used this kind of self-checking that simulate the outcome of this plan. Does this make sense? If not, repeat the plan. And there are some multimodal checks that did actually reach the state it was intended to reach. So then how could we agent improve itself while playing? So now so far we had agent acting in the environment and making sure the plan works. How could we make it just improve itself during playing? So reinforcement learning people really like this part because we want our agents to improve as they play. So with code, you just could store and retrieve the subroutines or the solutions you came up with. So in the going back to Voyager and now completing the loop on the Voyager actually is, one, you ask the LLM for a sensible goal to reach. So it knows what it has reached before and it knows the state. It asks what would be a reasonable new goal to reach, but something that's feasible and like close by. And then it picks that and starts executing on that. And once it solves it, then it stores that stores the code of that solution into memory. So it has that skill. So next time, I don't know, it wants to build on that, it can just call that subroutine. And then repeat this loop as long as you're satisfied. Or take a vector database approach where this MP5, they use a bit more clever, bit more complicated solution where previously solved sub-goals were stored in a vector database. So you could then query when you see similar sub-goal, could query it for potential solutions and then reuse them if applicable. And then how about the creative and the vague human-like tasks? So we have been talking about concrete tasks again, going back to this creative vagueness thing. How about this? So we can use the LLMs and other big models to clarify a creative goal. So creative agents, you get a instruction on the left, just to build a sandstone palace with very little instruction. And you can just ask an LLM, come up with the steps, how to do this, much like in the other, much like I did. They also test with diffusion models, like imagining the goal, and then they use different ways of trying to execute the plan with code generation or just behavioral cloning controller. And then finally evaluate, this is the fun part with these papers, by the way, evaluating the results. They use GPT-4v, probably a decent, and then actually humans to check that if the result matches the requested construction. Or you can just use the vision LLMs to directly pick good solutions. So Lubam used a multi-agent solution with various different components of decomposing the thing and so on. With the main focus or the main ingredients was that it used vision models to kind of check if the solution is visually appealing and it fulfills the functionality. So for example, a house has a door, or a house has a windows, or a bridge is actually connected all the way through. So they just rely on the actual vision capabilities of LLMs, of multimodal models to get to this point. So we have talked a lot about this. Oh, I have talked, you haven't talked, no, squash. But let's summarize the 2022 and 24. So it's now covering much more of the item tree of Minecraft. So instead of just getting a diamond, you get all of these different items, go even beyond diamond in terms of like complexity, and in a very clean solution. So here's, for example, the Voyager just keeps on climbing the longer you run it. Depends on how many dollars you want to spend on running the LLMs. Moving beyond simple instructions. So we had very simple, like obtain a grass, obtain a seed, obtain a log. We moved that from that to very multi-part ones. So dig a block of sand near water at night with a wooden shovel, or otherwise more complicated tasks that require multiple steps. And the instructions are getting more vague. So we can also, instead of just getting, like saying, get me a diamond, get me a stone pickaxe, we start to see this yellow concrete Minecraft house, and then it builds something that resembles a yellow box, I guess. So we're getting there in terms of the vagueness. So finally, some clips of the agents going because I didn't have them before. Gonna be a little bit choppy, but I hope you get the idea. On the left, it's a ghost in Minecraft, which is a bit older. On the right is Jarvis. On the right, if you can imagine the frames between the frames you can see, it's actually heading for a tree to cut it down and used an axe to cut it down faster than just with hands. You don't need an axe. It just makes it faster. So it used that to cut down the tree, and then it very intentionally, crafts them into sticks and planks and builds wooden pickaxe. So it's way more directed, like it knows, well, very subjectively, it seems to know what it's doing. And the results replicate that so that these agents are able to get many most basic items in Minecraft. Bit of a extra slide. There is a startup now also called Altera AI that's quoting from their webpage. Our mission is to create digital human beings that live, care, and grow with us. They are using Minecraft as a benchmark. I'm just a random clip video of them showing their world where they have a bunch of AI models running around, and I don't know, in this example, they're talking about missing villagers and they go find the missing villagers, and it's just like LLMs interacting with each other in a more social manner. So this is like what they're doing, like a very multimodal Minecraft setting. We don't know exactly what they're running yet. They are relying on GPT-4o, but they're saying technical report is coming soon. If you're interested, you can try their AIs. They try to apparently sell this as you can connect their AIs to your server. So if you have Minecraft and stuff, you're curious, you just go to their webpage and they have like a thing where to try our agents and you can get them on your webpage server. But I don't know about you, was this very mind-blowing results, what I discussed? A little bit nods, a bit of a shaking head, shrugs. For me, it's while they're good and improvements, I don't find them super mind-blowing. And why? In my opinion, the LLMs brought much of the intelligence. So we already knew that LLMs are very good at splitting the task and giving you details. So if it's already able to describe the world and come up with the plans, that's already doing a lot of heavy lifting. The non-algorithmic changes in many of these papers, especially in the older ones, there's a lot of little changes in the paper or in the environment that make it easier. So here I'm trying to show that if you can see it, the blocks, when it's digging, they destroy immediately. So remember, it takes actually a couple of seconds in a normal game to destroy a block. But in this goes into Minecraft, not to point any fingers, it destroys them immediately. So this is somewhat common trick to make it easier to train these agents, because it makes it a lot easier to just get items and makes the whole exploration problem more easier. If you're a reinforcement learning person, you can imagine trying to learn cutting the tree, like spending there a couple of seconds, like 20 actions, is a bit difficult. And then there is more to Minecraft than just obtaining items. So not just obtaining items, there is more stuff to do. So these are the reasons why I don't really find it super mind-blowing. So what then would be mind-blowing? Oh, no, it skips. Hold on, I'm just giving it I'm giving it a little bit of time to catch up. So what would be mind-blowing? So simple take, AGI should be at least complete all the tasks many humans have. So anything, I don't know, many is a very related term, but people who do it normally in Minecraft. So with the same constraints as humans. So you see the video impact, you hear the audio, you have a keyboard and mouse, and you have access to internet or Wikipedia, because, well, those who have played Minecraft know that you need some kind of internet access to ideally be able to figure out what to do next, how to craft an item, or what even find in the world, because it's so fast. So basic example of what would be cool, a little bit mind-blowing, is defeating the Ender Dragon, supposedly one of the bosses of Minecraft. I mean, it doesn't end the game, and it's somewhat recent addition, but this would be one clear goal, that you defeat an Ender Dragon in 24 hours, just to put the pressure on the model. You can add bonuses on that, like just extend it a little bit, make it kill the Ender Dragon without dying, or without dying and in 1 hour, so it becomes more like a speed run. So you have to really change your tactics, how you go about things. Or just adding more things that obtain Elytra or other endgame items you get after killing the boss, or getting as far as like people consider endgame items, trying to find this. Still interesting, not super, I don't know, complicated. Another route you can take is, say, obtain 1,000 gunpowder in 24 hours. So in the game, normally to get gunpowder, you have to kill creepers, enemies that spawn during the night, and they sometimes drop gunpowder. I'm not sure if you can get 1,000 gunpowder in 24 hours. So instead, what humans do when they want to obtain a lot of gunpowder or something, they build these things called mob farms, where enemies are designed to spawn enemies, or like they abuse the Minecraft mechanics to spawn in enemies and then automatically kill them in some way or another and get the loot, get the gunpowder, bones, whatever, to really like, I don't know, make this industrial. So then you just get this stuff automatically into your chest. So this would be very cool for AI to be able to do. Like you tell it, get me this 10,000 gunpowder, and then it figures out, okay, I need to build these things, and then go from there. Requires building a large structure, but the thing is, many people have done this. You find YouTube videos, you find Wikipedia pages or blog posts with exact schematics down to the block, how to build these things. So while it is interesting, it is not quite mind-blowing. I mean, definitely I would be happy with this though. So my take, I'm probably many of you also have the same take, but it should also complete very novel-ish tasks. So tasks that are not in the pre-training datasets or training datasets, ideally not on the internet or very low, very limitedly documented on the internet. So then it will require exploring the in-game content, studying the mechanics, trying to understand the interaction with objects. Maybe you give it the access to Minecraft source code so it can understand how different things interact and so on. So as an example, you could use game mods, which modify the game in many, many, many ways. You could use this one game mod called Nethack Ages, which adds a lot more stuff into the game, and tell it to get me 1 million paper clips in some hours. And this is a very long progression. You start the game in Stone Age, essentially, and you have to start building from like different ages to like space age. You go to moon, and you start harvesting meteors or something. And from the meteors, I don't know why you need meteors, you can do paper clips, and now you need to make millions of those. So it is very long, just a very long route to get there. And there's not too many documented ways to do it. Like you see people, I took this from Reddit, showing off their factory how to do it, but there is no like instructions how to get there. So it's a little bit more novel thing to do. And then my favorite take, connecting humans with the AI. So in all of these works, only very, very few connecting with humans with AI. And even then it's more about connecting, using humans as an evaluation tool. So, but making this AI AGI is like, the point is that we want them to help assist, augment us, to help us with mundane tasks or less mundane tasks, ideally not make us unemployed or anything, but still help us with things. So we should involve humans as part of the AI development or the training loop and more in the research. So like questions, how humans use the AI, how AI reacts with the humans in Minecraft setting, and so on. And Minecraft is a humans first environment. So it's not an environment designed by AI people with, I don't know, tricks to make it easier for AI. It's a human environment designed for humans. And the AI is coming there, kind of like coming to natural world. You have hundreds of thousands of players. You can get data, you can get feedback, you can invite them to your server to play with the AI. And the Minecraft is very well understood by humans. Like we know the optimal solutions, we know how to do things the best way. Although it also still pushes new solutions. I just learned about this thing called drag clicking, where you somehow modify your mouse to like drag your finger over it, and it causes like multiple clicks per second, like a lot of clicks per second, and this allows you to place blocks way faster than you can normally in the game. So, and this is somewhat recent, I think. I didn't even know about this until last week. So it still pushes kind of the things we do. Challenges, I mean, you have the alignment and safety, communication with the humans, just general planning capabilities, technical restrictions, so you have to run it in real time and so on. So a couple of just examples. How are we actually doing on the time? Because this is my final slide. Oh, still have plenty of time. But a couple of examples. You could take any humans, and they are completing a grand task. And now you take another M humans that help doing the task, but you replace those M humans with AIs and see if the AIs can still help the original group to do the task. So essentially, replacing the humans with the AI, a part of them, and see if they can still complete a grand task like a construction in the same time, or even faster by, I don't know, telling the AI, go get me stone, go get me sandstone, or craft me some weird items. More boringly, we could just reach for the basalt benchmarks human level. So build a waterfall, build a house, and have it to come to a level where humans prefer the AI more than other humans completing the task. Is there a question?
Are these simpler games where we have reached this point?
Which point? The second point?
Connecting interface with, yeah, I guess either of them.
I mean, on other games.
I Counter-Strike, I don't know.
If n equals 0, they're lots of games.
Yeah, there's a lot of games, but connecting AIs, especially in this way. I need to think on that. Let's chat after the presentation. And the final one, say, given the last 1 hour, what human player was doing, there's a bit more, this might start getting a bit more ethical and stuff, but last 1 hour, what human player was doing, complete whatever they were doing while the player sleeps. So you're building one of those big structures, you go to sleep, and the AI meanwhile has completed what you were doing. They figure out what you were doing and what should be done. And a bit touchy because then it kind of cloning your behavior. But that's actually all I have for now. So thank you for listening. I hope you got a good summer.